Okay, so we're going to be practicing MRAM. So rectangular approximation method is used to approximate area under a curve. Okay, so we're going to be using MRAM to estimate the area under the curve from 0 to 6 using 12 intervals. Okay, so that means that my width of each of my rectangles, since my total distance is 6 and I'm using 12 intervals, I have to split those into half. So let's draw a real quick picture. Okay, so obviously let's draw the function. So we have the quadratic at 0. I'm going to make each one of these 20. It's 20, 40, 60, 80, 100, 120, 140. Okay, and I'm still going to keep these 1, 2, 3, 4, 5, 6, 7. Okay, and there's a reason for that because this function, since the quadratic gets really big at values and it's been stretched up, it's going to cause us to have issues if we try to leave the x and the y. You won't really see the function at all. Okay, it'll shoot up off the graph. So at 0, we're somewhere here. We're not at 0, we're at like 2. Okay, now you could use a calculator to help you kind of sketch it to see what it looks like. But I know basically that at like 7 we're around like 140 somewhere up here, and then around 5 we're somewhere around 70, so something like this. And at 3 we're somewhere around 20. So my function looks something like this. Okay. Now, I'm using MRAM, okay, which means we're going to hit, our rectangle is going to hit in the middle, okay? So, since my beginning's at 1 and my 6 is my area from 0 to 6, that's what I'm looking for, I'm using 12 subintervals. So basically, each rectangle is going to be a width of 1/2. Okay? Now, because I'm using MRAM, the heights of these rectangles are basically going to be in the middle of that. So right here, the height of this rectangle hits in the middle of the function. Same thing for my second one. Hits in the middle. So right here, this is the height. Here's my rectangle. Okay, so these are the way my rectangles look. It'll be easier to see when we get towards when it gets deeper. So like this one here, this one here, this one's going to hit somewhere like right here. Okay, this one right here. And then my last one hits somewhere like this. Okay. Now, and basically, this rectangle, we could use a bigger one. So this rectangle right here hits in between. This is 5.5 and 6. Or think of it this way, this is 0.25. This, because 1/2, this is half of it, this is 0.25. So the height of my first rectangle, so when I go over here to fill in my chart, my first one is 0.25. And then this one's between 1/2 and 1, which is right in the middle, 0.75. And then 1.25. And then 1.75. So these are the values, 2.25, that I'm going to be putting into my function. Okay, so 3.25 and 3.75 4.25 and 4.75 and 5.25 and 5.75. Okay? So again, I'm not using the left side, I'm not using the right side. Their heights of these are coming from the middle, in between 0 and 1/2, which is why we use 0.25. It's in between 1/2 and 1, 0.75. Okay? So we're using midpoints, which makes it a little bit more difficult just because the numbers are going to be kind of squirrely. So the next thing we're going to do is we're going to take all these values and plug them into our function to see where the function is at 0.25. And that's at 2.1875. And this one is 3.6875. And then 6.6875. 11.1875. And you can start seeing these numbers repeat. The decimal is 17.1875. And then 24.6875 and 33.6875 and 44.1875 and 56.1875, 69.6875, 84.6875, and 101.1875. Alright, again, all of these are not area, these are heights. These are the heights of the rectangles, okay? So, but since all of my rectangles have the same width, I can add those up, okay? So my total height, so T for total, add all of these up, I get 453.0625. Okay? Then I use that to find my area, because my area is going to be my total height times my width. And in this case, my width is a constant 0.5. So when I multiply that 453.0625 times 0.5, I get 226.53125, and that's my answer. Now, which isn't bad, because the actual area is 228. So that is pretty close.